MoNaCo here, doing another shirt today, so I needed a little pick-me-up. I wanted to show you the flame test in the lab for the different metal ions, how they change the color of our flame here. Say hello, Mr. Milks, you're holding the camera.
Hello, Mr. Milks, I'm holding the camera.
Classic.
Gotta do
So
it.
what we have here is we have a Bunsen burner. You can't see it so well with the lights on. You can't see this flame test so well with the lights on, so I'm going to turn them off. I'm going to test 4 different chemicals down the line here to see what color they turn the flame. And the reason why this happens is what I'll explain afterwards. So go lights out here. This flame is burning blue, normally just like the stove gas at home. If you have an electric stove, I'm sorry, you get to miss out on the cool blue color. What I'm doing here, this little loop we call it, I'm putting some of this chemical. This stuff is lithium chloride. I'm gonna just kind of pet the flame with it. Woo-hoo! This really awesome, beautiful magenta color is characteristic for the lithium ion.
Yo, that's wavy.
Mad wavy. And it's light, which is a wave. Punny, I know. So I don't want to hold it in the flame too long because then it all burns off and then the loop starts to burn, which gives us a different orangey kind of color into the flame there.
Yeah.
Okay.
So just as a little note from the video taker,
Yeah.
what I'm seeing on the screen, whoa, is not what I'm seeing in the lab because the middle of the flame looks really white. I'm hoping that comes out good and nice and red, but you notice the top of that flame was really
Purple,
red.
pink, red, magenta. It was
Right.
beautiful.
In the lab, lifetime, that whole flame was red. So we'll see how that comes out in the video.
Camera doesn't do it justice.
I'm interested to see how it comes out. Definitely.
Sodium bromide. So this next metal ion is the sodium ion, and it's a bright orange. You can tell it's kind of
Definitely a different color.
beasting out a different color there. So different element, different color. Let me turn off these gas jets as we move along. This next one is barium chloride, and traditionally it's a bit challenging to see. So what I'm going to do, I'm going to get my loop a little bit wet, pick up some fresh chemical. It's a flaky powder. This one tends to be quick and very similar to the sodium there, but this has got a greenish tinge to it. So a green, yellow kind of color. There we go. Got a little bit of it in there. But the orange from the tester loop starts to show through. And this is another one you really got to see live time. And this last one we're going to do, my personal favorite, we actually discovered it this year when we were setting this lab up. This is Potassium K. And the best way to see this one is actually to sprinkle some of the dust into the flame, making a horrible mess as we go. But the best way to see the color that it's turning the flame, right there, it's turning the flame like this light kind of lilac purple color. Okay, so that is flame test. The cool thing about flame test is you can use the colors that these elements are burning to identify unknowns.
I think the real question is this, though, Mr. MoNaCo.
Yeah.
Why does the flame turn a different color?
Well, the flame turns a different color because the different elements have different numbers of electrons.
So they each have a different energy associated to them.
Yeah, let's go turn on the lights. Let's use some electrons to excite some lights and emit colored light in the lab.
Okay.
The electrons that are traveling through our tube lights up there are exciting the gas in the tube light.
Right.
That gas in the tube light doesn't stay excited for very long. It relaxes back down. And when it does, it releases a wavelength of light that is white.
And that wavelength of light just happens to equal the amount of energy we put in to get the electron to move.
Right, so when we were putting energy into the with the Bunsen burner flame, it was exciting the electrons in lithium. They were jumping up, and when they fell down, they didn't give off white or blue or anything. They gave off purple, or red,
Right,
magenta.
which is a wavelength for that particular color.
Related to the distance those electrons are relaxing back down to the ground
that
state.
energy. Very good.
There's a video on our channel about excited versus ground state
Sure.
electrons.
Sure
It
there is.
helps explain it. It's a really cool concept, and thanks for watching. We had to get some.
That was cool, right?
Yeah, we got another one to show you. This was with solids. We're going to show you with gases how that behaves. Too.
Oh, okay, good.
But it's a lot quicker.
Stay tuned.